Okay, ladies and gentlemen, we are talking about similar figures today. Okay, example 2. It says find missing measures in similar figures. It says a picture is 10 inches wide and 8 inches tall. To display the picture on a web page, the picture must be reduced to 3.5 inches tall. How wide should the picture be on the web page for the two pictures to be similar? Okay, to do this, you need to set up a proportion. It says let W be the width of the picture on the web page. Okay, so look at how they have this set up. The numbers across the top go with which one? Original or what page? Original. So they put the width, 10, lined up with the height of 8. Okay, because that goes with the original figure. The one on the bottom is going to go with the figure that's on the web page. Do we know the width of the web page picture? No, we're going to put W. But we do know that it is 3.5 inches tall, right? So now we can use cross multiplication to figure it out. So we're going to go 3.5 times 10, 35. Divided by 8, and it tells you right here what it is. It's going to be 4.375 inches equals the width of the picture on the web page. So when you set the proportions up, you need to make sure that you're lining these up. Original across the top. The reduced size is going to go on the bottom, the web page. You have to make sure that they're lined up correctly. A souvenir model of the pyramid over the entrance of the Louvre in Paris has faces in the shape of a triangle. Two sides are each 4 inches long, and the base is 5.1 inches long. On the actual pyramid, each triangular face has two sides that are each 27 and 8/10 meters long. What is the length of the base of the actual pyramid? Okay, so if you drew a diagram, it would help you visualize the problem. This is the one that's above the entrance, and here's the actual. Okay, so it tells you all of the dimensions that you need to know on the first one, but you're missing the base on the second one. So to set up your proportion, you put the small triangle information across the top and then the larger triangle information across the bottom to set up your proportion. What is the side length of a small triangle? The small triangle. People. What is the side length of the small triangle? 4 inches. What is the length of the base of the small triangle? 5.1 inches. It needs to go across the top. Across the bottom is your larger triangle. What is the side length of your large triangle? 27.8. And we're solving for the base. So you have to do it. You will get it wrong every time if you do not do this. Across the top is the one object we're talking about, small. Across the bottom is the other object we're talking about, which is the big triangle, the large triangle. And then you have to keep them lined up this way. Both of these measurements is what part of the triangle? Side lengths. Both of these are talking about the base. So you have to have it lined up in both directions across the top, and then making sure that whatever you're measuring is stacked on top of each other. Okay, so cross multiplication says 27.8 times 5.1 is what? So we're going to multiply that. You get an answer. What do you do with that answer? Good. So you get 141 and 7/800 divided by 4. And you should get x equals 35 and 445 thousandths. Label?
Inches. Centimeters.
I have this wrong. It should be meters.
I knew it. Told you.
So you would say that the base of the larger triangle is 35 and 445 thousandths meters. Okay, on your worksheet, it's going to ask you what triangles are similar. You need to prove it. There's two ways you prove this. You talk about the angles and you talk about the side length ratio. So you have 3 triangles, ABC, DEF, and GHI. So when we talk about which ones are similar, the first thing that I would look at is your triangle angle measures.
So it's AB.
ABC, RTS, and JMK are similar.
Okay, so if you look at this, you have 26, 90, and 64 for your angles on the first triangle. The only other one that has those triangle measures or those angle measures is this one right here, right? So to prove it, this is what you have to do. You need to say angle A is congruent to which angle on the other triangle? F. Then you would say angle B is congruent to which other angle?
The other.
D.
D. Listen, this one is not similar because the angle measures are not the same. They must be the same. Angle C is congruent to
E.
angle E. Okay, you've just proved that they're similar by one part, their angles, but now you need to talk about the ratio of their side lengths. So you're going to do AB is going to be congruent to which?
FD.
It's the hypotenuse. So you're going to say yes, FD. You have to use the same part of the triangle. If you need to, you can rotate it around and redraw it if you need to. Because see where the right angle is on here? It needs to match up with that. Okay, what is the length of AB?
6.7.
Yeah, that. 6.7 feet.
What is the length of FD?
13.4.
Oh,
F.
feet.
Oh, I forgot.
Get it right.
What does this reduce to?
2.
It does reduce to 1 over 2,
Oh.
right? 1 over 2?
I don't understand which graph.
What? Okay, so now we need to check the other side lengths. Let's do side length BC is proportional or should be proportional. We're checking to which one?
3.
Which DE, this one right here. Because if you rotated it around, that's what would line up with it.
3 and 6.
DE. So you're going to say BC is 3,
6.
DE is 6. Does that reduce to half?
Yeah.
Yes.
So they're gonna be proportional.
Not. You got to check the third one.
Well, you can't see that.
AC is, you have to prove it with writing though,
But 6 and 12. So half.
is FD. AC is 6
So we're
and 12, which is a half. So you would say that triangle ABC
It's proportional.
is similar to triangle DEF.
So all I have to do is write down.
No, you have to do all of this. You need to show me that the angles are the same, congruent. You need to show me that the side lengths are proportional. If you are doing a rectangle, how many of these will you have? 4 of them, because you have 4 sides, right? On a rectangle, how many angles would there be? 4.
West.
So when you're showing me that they're proportional, you need to do 2 things. You need to show me that the angles are the same. You need to show me that the side lengths are proportional, which means that you're stacking your ratio with the 2 side lengths you're comparing, and your reduced ratio should be the same on all of your side lengths. And then is it? Yes, it is. Are there any questions on this?
No, ma'am.